For these last three problems on our homework, I'm not going to show you how to put the values in your calculator. If you have questions about that, please check out the earlier videos. Instead, I'm just going to focus on how to read the contingency tables, how to set up the probability, and obviously show you what the answers are. So all three of these involve contingency tables, and they get sort of their various levels of difficulty. Part of what makes the contingency table and 4 so challenging is the numbers are just so big. We have COVID dashboard numbers from back in 2021 on this first table, and we're asked what sort of is the likelihood that these certain, people fall into certain subgroups. So here we have, what's the probability that a person in this group was male? And so for this first one, we're not given given that they also were 20 years old. So we're focused on that total number in our table, and that's going to be the total that our probability is out of. So the 2,885,381. Now, male, oops, that was supposed to be highlighter, not pen. Male would be everyone in this column. And so the total there at the bottom is the number we care about. So there are 1,320,084 males. And there's my probability. If I put that into the calculator and divide, I would find that that's a 45.8% chance that a person who had COVID up to this point was male. All right, next one, we're looking at 20 to 44-year-old females. Now, this is interesting. So, in my head, I actually have two groups going on here. I'm looking for people who are both 20 to 44 years old and female. But what you don't see there is the word and. It's sort of missing because often we don't. It's implied. That statement implies that and overlap is going on. And so think about, we got our 20 to 44-year-olds, and we also have our females. And where do those two highlights overlap? The 443,804 number. And that's out of our total in the table, which gives us a likelihood of 15.4%. Next task is an or. So remember, or is an either. We have female or 65 years and older. So 65 years and older is that bottom row. And female is the whole second column here, third column. And keep in mind we have an overlap here. So there's two different ways we could go about doing this. Option one would be to add the number that's of 65 years and older and male to all the numbers in the female column. The other option is to say, well, we have a total of 1,565,297 females plus the 1,035,212 65 years or older. But in doing that, we added this overlap twice. So we would actually take out that overlap number of 537,308. And that's still out of our total 2 million. And that simplifies down, to a sort of, nicer 2 million number. And when you go through and find the percent, you wind up with 70.3%. That's one option. There's a bunch of different ways to sort of approach the ORs, but the key thing is thinking about that it's a big group of people. Last but not least, we are dealing with less than 20 years old, given that the person is female. Keyword given. That means we have a subgroup going on, and our subgroup are those females. So I don't care about my whole table. I now only care about the female column. So what I've highlighted in orange is all I care about, which means my total now is not the 2 million, but it's the 1,565,297 females. And of those females, how many were less than 20 years old? So if going here, less than 20 years old is the top row, and that's only 49,000. And so setting that up, it's only 3.1% of that subgroup is less than 20 years old. Next problem, it's on the same page for you guys, but I gave myself a little extra space. We have some market research going on. We got different, respondents from each country that responded to the survey, and this is some sort of background information about their schooling. So often when surveys are conducted, and we'll learn more about this in our statistics unit, we'll find that they ask demographic information to sort of see, can we make some generalizations based on these smaller subgroups? We need to, on this one, interpret our questions into some probability notation and then set up the probability that we're finding. So the first one, what is the probability that a person is from France or did some postgraduate study? So we have the probability that you're France or postgraduate. So postgraduate would be this whole first column, and France would be the second country row. And this is a big enough table that using that shortcut of, okay, well, we have 379 postgraduate students and 1,532 people from France, but I added my overlap twice, so if I subtract that out, it makes it a little quicker to do this particular calculation. And we end up with 1,842 out of that total on the table. So we don't have a given, we don't have a looking at this group, so we're down at that total on the table, and that ends up being about 24.1% of the respondents. All right, next problem. What is the probability that a person is from France and, so this time we're looking for the both, finished only primary school or less. So this is France and primary school. So I have my France column, or row, I should say, and we have my primary school or less, and where do they overlap? That 309 number right there. So 309 out of the 7,645 students, or not students, respondents, gets us only 4% of the people on the table. There's a 4% chance of finding someone in that particular group of people. All right. Oh, notice, ding, 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 keyword given. So we now have a subgroup. So given that respondent is postgraduate. So here is my subgroup. What is the probability that the respondent is from the US? So postgraduate, notice we only care about this first column, and there are 379 people in that first column, and we want to know what's the likelihood that someone's from the US. Well, there are 84 postgraduate people from the US, so that's 84 out of 379, which is 22.2%. And I should write out my probability notation. So probability of US given postgraduate. All right, we got another given that the respondent is from the UK. So there's our subgroup. And so going up to our table, how many people are in the UK? 1,537. And what's the probability that he or she has a high school diploma? Now this one is tricky. And here's the tricky part about it. If you are getting a master's degree, you have a high school diploma. So my postgraduate group all has a high school diploma. If you are in college, you also have a high school diploma. And saying that you completed high school means you also have a high school diploma. So 3 of my 4 columns all involve high school diplomas. It's only the people with primary school or less who don't have that high school diploma. And so we actually have 1,505 is the probability that, they have a high school diploma given they're from the UK. And that's 97.9% likelihood of finding someone. All right, last but not least, what is the probability that a respondent who only has a primary level education is from China? So this is sort of our subgroup, only has that primary level education. And we want to know within that subgroup, what's the likelihood that that person is from China? And so I like to highlight my subgroup, so primary school education, and then China is the top number. So of those 1,161 people who only have a primary level education, 506 were from China, which is 43.6%. And that probability, China given primary school. All right. One last problem. It's another contingency tables. By now, this should be somewhat familiar, so I'm not going to take quite as much time on it. But I wanted us to get some, comfort, more familiarity. And this time we're back to the probability notation. So it's just sort of interpreting things. So we see the line. We should know we have subgroups. This 18 to 24 is my subgroup, which means we're only looking at 18 to 24-year-olds, which there are 604. And we want to know of that, what's the likelihood of picking someone who uses e-cigarettes? And there are 133 of them, which give us a likelihood of 22%. Notice D is sort of the reverse of that. We have our subgroup of e-cigarette users, which would be the 599 number. And of those 599, 133 are in that 18 to 24 demographic, which is, believe it or not, almost the same percent. Those are pretty similar totals, just slightly different. In general, though, what's the likelihood of finding someone in this, state of Arizona survey data that is an e-cigarette user? That's the 599 people who used e-cigarettes. But out of all the people surveyed in this CDC study, and so that's the 10,108, and that ends up being only a 5.9% likelihood of finding an e-cigarette user, so not high. People who are e-cigarette users and 18 to 24, there are 133 of them. So this is going to be even a smaller likelihood because, we're limiting the group to the both. And yep, sure enough, that's 1.3% of the users. Versus I belong to either the 18 to 24-year-olds or the e-cigarette users. So we could think of that as the 604 plus 599, subtract out that overlap of 133 out of our total, and that numerator simplifies down to 1,070 out of 10,108, which is about 10.6% belong to one of those two groups. Last but not least, a conditional. Our subgroup this time is over 65. So if I go back up to my table, how many people are over 65? There were 3,000 787 respondents who were. And of those, how many used e-cigarettes? Not very many, only 67. And so there was a 1.8% chance that in that senior citizen group, you would also have an e-cigarette user. Hopefully these videos give you a better sense of how to find probability when given contingency tables.